Channel. I am Nivedita, Assistant Professor, Department of ECE, MIT Mysore. In this session, I will be explaining about the concepts of oscillators. Before going to the in-depth of oscillators, let us see what is an oscillator. Oscillator is an electronic device which produces a continuous oscillations in terms of sine wave, square wave, triangular wave, etc. How it's going to produce a continuous oscillation? It is a circuit of amplifier which continuously produces an oscillations with the help of having a feedback positive. That is, oscillator can also be defined as oscillator is an amplifier which is provided with a positive feedback. As I told you, oscillator is an amplifier. So in the circuit you need to have a block called amplifier which is having an voltage gain of AV, which is as shown in this particular block diagram. It is a amplifier which is provided with a voltage gain AV. Next, what is the next block we need to include? As I told you, oscillator is an amplifier circuit which is employed with a positive feedback. Here I include one more circuit for a feedback which is called as a feedback network, and it is provided with a feedback ratio beta. Feedback ratio is nothing but a part of output which is fed back to the input. It is a portion or what is a percentage of output which is provided to the input. That is always denoted by beta. After these two blocks, for any circuit, as we know that we need to apply an input and we have to draw the output. So where is the input now? The input to this entire circuit is Vin, and the output which is drawn out by the circuit is Vout. Okay, and here for the amplifier circuit, what is the input we are giving? So we are giving a input along with the positive feedback value. Okay, positive feedback refers to the reinforcing of value, that is the value will be added to the actual input. So now the input what is going to the amplifier is taken as Vin dash. It is a sum of Vin plus beta into Vout. Okay, knowing this, let's derive an expression for overall gain of this particular oscillator circuit. So every time when we go for an overall gain, we denote that overall gain with capital G. Okay, so it may be a normal gain or an overall gain. It is always a ratio of output to input. Here I'll go for a ratio of output voltage to input voltage. So now I'll write G as Vout divided by Vin, and I'll call this as equation number 1. So in these two, Vout and Vin, which is there in equation number 1, we need to have a substitution. For a Vout, what is the substitution we are going to get? And we have a normal gain which is given with AV, and here also it is a ratio of Vout by Vin. Vout by Vin. From this equation, try to write an expression for Vout. So what is Vout? Vout is AV into Vin. I'll call it as equation number 2. For Vout, which is there in equation 1, we got a substitution, right? So after that, we need to have a substitution for Vin. Vin is a overall input of this particular circuit, right? So what is Vin? So that you have to write. Before writing a Vin, I'll write an expression for Vin dash, which is the input to amplifier circuit. What is Vin dash? Okay, so what is Vin dash? It is Vin plus the feedback ratio value beta into Vout. Okay, so from this equation, try to write an expression for Vin. So Vin is equal to Vin dash minus beta into Vout. Call it as equation number 3. Okay, and we have two substitutions. One is equation number 2 and equation number 3. Both can be substituted in equation 1, and here we need to have a one change, that is in equation 2 we have written a gain, voltage gain of this amplifier circuit. What it should be? It should be a ratio of output of the circuit and input of the circuit. So what is the input to the circuit? It is clear that it is V in dash. So what is the mistake I have made here? It should be V in dash, and this equation has to contain V in dash, which is taken as equation number 2. So now easily you can substitute equation 2 and 3 in equation number 1. That is, I will go for a sentence, substituting equation 2 and 3 in equation 1. In equation 1 we get, so what happens to the equation of overall gain now? It is capital G is equal to V out is AV into V in dash divided by, and V in is V in dash minus beta into V out. Okay, this is a simple substitution what we got by substituting equation 2 and 3 in equation number 1. You can also have a slight modification in this equation by substituting again V out as AV into V in dash. So substitute that, what happens to this? AV V in dash divided by V in dash minus beta into V out can be taken as V out is AV into V in dash. Okay, so you can observe the denominator term. In the denominator we have the two values V in dash in both the terms. You can easily take out that as a common factor, and overall gain becomes now AV V in dash divided by V in dash 1 minus beta into AV. So in the numerator also we have V in dash, and in the denominator also we have V in dash. These two will get cancelled. Finally we will get a equation for overall gain of oscillator as G is equal to AV divided by 1 minus beta into AV. So this is the final expression of overall gain of the oscillator, which is consisting of voltage gain, beta, that is a feedback ratio. The overall gain of an oscillator circuit is given by AV divided by 1 minus beta into AV. Okay, so since it is having a positive feedback, this equation is the overall gain equation for oscillator, and based on this simple equation we are going to have a basic problems. As this is for a second semester of engineering, it is quite simple problems which can be asked using the simple values which are calculated using this particular equation. The next topic of oscillator is the condition for oscillation. As I told you, oscillator, it continuously produces a waveform which may take a sine wave, square wave or a triangular wave shape. Okay. So in order to have a sustained oscillations, the oscillator should possess the two important characteristics, or it should have two important conditions. What are those? The first condition under that is it should have a positive feedback. So as I told you, oscillator will be always provided with the positive feedback. So that is the first condition. It should have positive feedback. Okay. And the second condition is the overall loop gain of oscillator should be greater than 1. So the second condition is the overall loop gain must be greater than 1. Okay, so these two are the conditions of oscillations which are must have for the oscillator circuit. These are the conditions of oscillations. Okay, so after this we'll move to the types of oscillator. We have a lot of types in oscillator. So under that I am going to explain the first type here, which is a ladder network oscillator. Why we are calling it as a ladder? Ladder because we have the three combination of capacitor and resistors here which are connected in a ladder fashion. So that is CR, CR and CR combination. So these are representing a ladder network. So after this, here we are making use of a transistor. So as we know, the transistor in an active region, it works as an amplifier. If the amplifier is provided with a positive feedback, it acts as an oscillator. Hence, in an oscillator circuit, we are making use of transistor which is denoted as TR1. And transistor is having three terminals. So, emitter, base, collector, and emitter is being grounded here, and these is connected to a resistor and capacitor in order to provide a emitter stabilization. And also the base is connected to the two resistors R1 and R2. These two acts as a potential divider circuits or a resistors. And here the output will be drawn out from the collector terminal. And this type of oscillator, it produces a certain frequency of oscillations, and that frequency is given by the equation F is equal to 1 divided by 2 pi square root of 6 into RC. So this is an frequency equation of this particular oscillator. So here we have a root 6 value, and for every stage of RC ladder we have a root 2 value, and that is finally taken as root 6 1 divided by 2 pi root 6 RC. Okay, and this is about the ladder network.